Welcome to the deep dive. Today we're looking at something really quite pivotal in AI.
Absolutely. A moment that's kind of reshaped how even experts are seeing things.
Yeah, we're talking about OpenAI, their latest general-purpose reasoning model. It just hit gold medal level on the International Math Olympiad, the IMO.
Which is just staggering, honestly. Something many thought was, well, pretty far off.
Exactly. And this isn't just, an AI getting good at sums. It feels much deeper, like a real breakthrough in reasoning.
That's the core of it. And our mission here is to really unpack what this actually means.
Right.
How did they do it technically? And maybe more importantly, why this is so much bigger than just math.
It touches everything: science, education, the economy.
And it seems like that future is arriving, well, a lot faster than we were expecting.
Yeah, Philly. My first reaction was just, wow, pure astonishment.
Right, too.
Because it's a general purpose AI, right?
Right.
Not something purpose-built for math contests.
Exactly. It wasn't fine-tuned specifically for IMO-style problems.
And yet, here it is, performing at this super elite level.
Yep.
You mentioned how fast things are moving. Wasn't a previous model ranked like 800th?
Yeah, just a few months back,
Yep.
around 800th on this exact benchmark.
And now,
Now, this new internal model has almost saturated the benchmark.
saturated. That's incredible. People thought that was decades away.
Easily decades. So, yeah, the acceleration is just phenomenal.
It really points to something fundamental changing in AI reasoning, doesn't it?
Yeah.
That kind of leap in such a short time.
It absolutely does. It's not just incremental progress.
So the big question then is, how? How did they actually pull this off? Because you said it wasn't just more data or longer training.
Right, that's key. It's not the usual suspects, so to speak. The real breakthroughs seem to be in two areas.
Okay.
First, something called inference-time compute scaling.
Inference-time compute scaling.
Mm-hmm.
What does that mean in plain English?
Think of it like giving the AI more mental horsepower, but specifically when it's trying to solve a problem.
Ah, okay. Like more thinking time or power during the actual task.
Exactly. It lets it explore more options, go down deeper logical rabbit holes, more bandwidth when it counts.
Got it. More mental bandwidth. And the second area,
Advancements in the AI's reasoning architecture.
so the internal structure, how it's built.
Yeah, basically making the underlying structure more sophisticated so it can tackle complex problems in a more, well, structured, almost human-like way. Less brute force, more strategy.
So smarter thinking on the fly, essentially.
That's a good way to put it. A fundamental upgrade in how it reasons in real time.
That makes a lot more sense than just bigger model.
Uh-huh.
And this builds on earlier stuff, right? Didn't their O4 mini model hit a milestone recently, too?
It did. Earlier this year, it saturated the AIM benchmark, the American Invitational Mathematics exam.
Okay, so aim first.
Yes, and that was impressive. But jumping from AIM saturation to nearly saturating the IMO.
In just 2 months.
In about 2 months, yeah. It's a whole different league.
And IMO problems are notoriously hard, right? Not just plug and chug.
Oh, absolutely. They're proof-based, open-ended. They require genuine mathematical insight, deep reasoning, creativity even.
You need to build arguments, logical steps.
Exactly. Constructing rigorous proofs. That's why getting this good at IMO is such a massive deal for AI reasoning.
Which brings us to the wider implications. Because if it can do this, it's definitely not just about math Olympiads.
Not at all. Let's talk STEM acceleration.
Yeah.
How does this change things for science and tech?
Well, imagine AI tackling problems that are currently just too complex for humans alone, like designing new materials based on first principles.
Room temperature superconductors, maybe?
Potentially. Or think about quantum computing. AI could design and verify novel quantum algorithms way faster than we can.
Accelerating fields bottlenecked by human analysis.
Precisely. Math is the language of science, right?
Yeah.
An AI fluent at this level could fundamentally change the speed of discovery itself.
That's huge. And what about education? You mentioned that earlier.
Yeah, think about AI tutors. Not just
Mhm.
basic homework help, but like PhD-level tutoring in advanced math.
Right.
Available to anyone, globally.
That's the potential. Making truly elite instruction accessible to students everywhere, regardless of background or location.
That could completely change who gets access to deep technical expertise. Decouple it from traditional schools.
It really could, which ties into the economic side, too.
How so?
Well, if you lower the barrier to mastering advanced math, which is often a gatekeeper for high-paying tech jobs.
Then more people can enter those fields?
Exactly. It could democratize access to technical skills and drive pretty significant economic shifts. What happens when elite skills become AI-assisted skills?
It's a big question. And speaking of what seemed possible, you mentioned prediction markets. They didn't see this coming, did they?
Not at all. They were completely flat-footed. Before this news, the chance of an AI getting an IMO gold by 2025 was pegged at maybe 20%.
Only 20%. Wow.
And then after the announcement,
It shot up.
dramatically jumped straight to 85%.
That really underscores the speed, doesn't it? Even the experts forecasting this stuff were surprised.
Totally. It shows this isn't always a smooth, predictable climb. Sometimes you get these huge, almost vertical jumps in capability.
Nonlinear progress.
Oh.
Which brings us to that idea of AI as a general-purpose technology, a GPT. The source material used the analogy of electricity, which I found really insightful.
It's a great analogy because, like electricity, these foundational technologies, their real impact isn't obvious on day one.
Right. Electricity wasn't just about light bulbs.
Exactly. It took time to spread, for people to figure out how to use it, to build new things on top of it, factories, appliances, whole industries.
Things nobody imagined at first.
And AI seems to be on that same path. It's becoming this underlying layer. But what's really interesting here, almost unique,
Go on.
is the self-reinforcing cycle. AI research itself is heavily mathematical, right?
Yeah. Linear algebra, optimization, algorithms.
So as AI gets better at math, it gets better at the tools needed to improve AI.
So it accelerates its own development.
It's a feedback loop. Getting good at math helps it get better at getting better.
That's a powerful idea. AI improving its own intelligence. So if things are speeding up like this, what are the big societal shifts we need to brace for?
Well, that ties directly into the work I've been doing on post-labor economics with Julie McCoy.
Okay.
This IMO achievement, it's not just abstract. It's a concrete example of AI mastering highly complex intellectual work that was always seen as uniquely human.
Deep mathematical reasoning.
Exactly. And when that starts getting automated or augmented, it signals a really profound shift. It forces us to ask fundamental questions about the future of work, the value of human labor.
And how our economies might need to adapt, that great decoupling you talk about.
Precisely. This AI progress is a tangible driver of that decoupling between, say, economic growth and traditional human labor inputs.
So wrapping this up for today, what's the biggest takeaway for you, the listener, stepping back a bit?
I think it's realizing we're entering a new phase, where general-purpose AI stops being just a tool you use and starts becoming a fundamental layer.
Like electricity or the internet or mobile.
Yeah, exactly like those. Pervasive, foundational. It'll seep into everything, often invisibly.
Powering sectors and capabilities we probably can't even imagine right now.
And the really mind-bending part, for me at least, is that idea that math is, often called the language of the universe.
Right, the underlying rules.
So when AI masters math at this kind of level, it feels like it's starting to master the rules of the universe itself.
That's quite a thought. Opens up a lot.
It certainly does, both possibilities and, frankly, questions.
So maybe the final thought for you to chew on is this. What does it truly mean for us, for human potential, for our own intelligence, when an AI can reason mathematically at this highest level?
A level we've always seen as the pinnacle of human logic and creativity.
Yeah. What new frontiers does that unlock?
Right.
And what does it force us to ask about discovery, intelligence, and, well, our own place in a world increasingly shaped by these powerful new minds?